So basically, Lucas has already said many of the things that I'm going to present now. So, but he's like, I think he emphasized it. He's more on the methodological side of structuralism, and now it's going to get more metaphysical. And so I think I agree with like maybe 99% of what you said, but I just want to go a bit further. And I think that structuralist representationalism, but it also doesn't work here. Oh, wow. Okay, now it works.
Can this disappear?
I think it's.
Is it? Okay. I don't know.
Okay.
Okay, that's fine.
Okay, sorry. So again, the hard problem of consciousness, I think everyone here is familiar with it. So it is a problem of explaining why and how do physical states and processes give rise to phenomenally conscious experience. And we can even like divide it into two problems. There's the more general version of it. It is the problem of explaining why is any given physical state or process accompanied by phenomenal character at all. So we can ask, why does this state feel like something rather than nothing when I see this red apple? And on the other hand, there's the more specific version of the hard problem, and that's the problem of explaining why is any given physical state or process accompanied by some particular phenomenal character. And so when seeing a red apple, we can ask, why does it feel like this rather than that? And like, I will get back to this point later, but we will see that structuralist representationalism, as I presented, is only concerned with the more specific version. And I think this was also pretty clear in Lucas' talk with your two-factor view, that like the structuralist approach aims to tell us something about the content and character of phenomenally conscious experience, but it does not tell why some state is phenomenally conscious rather than not. So it can't explain this on-off matter. Okay, now representationalism is the view that the phenomenal character of experience can be accounted for in terms of its representational content. This is representationalism in a very like general outline. And what makes it particularly appealing is that physicalistically respectable account of phenomenally consciousness may spring off from it. So we can see it this way. We have phenomenal character, and now we have a two-step explanation or two-step account. And in the first step, you try to account for phenomenal character in terms of representational content. And then hopefully we can also account for representational content in terms of physical or functional properties. And if we can accomplish this, then we will have like this two-stage reductive explanation account of phenomenal character in terms of physical or functional properties. There are many more motivations, but I think this is like the most important one for the aims here. And now, of course, the representationalist has to say something about representation. So what is representation? How does a state acquire its representational content? And yeah, so until now, the most important like view has been to adopt the tracking theory of representation. And the tracking theory states something along the lines: a state S represents P if and only if S tracks P. And then we need to cache out. You can see, yeah, and then we, of course, we need to cache out what does it mean to track something. There are different approaches. The two most important approaches in the literature are those by Fred Dretske and Michael Tai. On the one hand, Fred Dretske says that tracking is a matter of having an indicating function or the job to provide information to a system. So on this view, a state represents redness if and only if it has the function or job to indicate instances of redness. And another view is that of Michael Tai. He says that tracking is a matter of causal covariation under optimal conditions. And so on this view, representing a state represents something as red if and only if under optimal conditions, this state is tokened only when there are red things out there and because there are red things out there. And what is maybe most important about this here is that both views are in some way externalist because they appeal to external factors such as history or environment of the subject in order to determine a state's representational content. Okay, now tracking representationalism is if we take the representationalist idea and the tracking account together, and this gives us the view that the phenomenal character of an experience can be accounted for in terms of what it tracks. And here's an example. For example, if we have a color experience with reddish phenomenal character, and this experience happens to track surface reflectance property XYZ, so that is some physical property of the object that is experienced. And then the idea of tracking representationalism is to say that the reddish phenomenal character of this experience is just representing the experience object as having that reflectance property. And now this may seem somewhat problematic, and it is because there are several objections to tracking representationalism. I do not have the time to go into detail, but just will present very briefly the most important objections to tracking representationalism. The first one is that it is charged for being phenomenologically inadequate because it faces what is called a qualitative and a structural mismatch problem. So to put it very briefly, if you experience something at red, it just doesn't seem to you to experience something as having a particular surface reflectance property, but rather it seems to have some primitive color property, but not a very special physical property. Then second, tracking representationalism cannot account for the possibility of reliable misrepresentation. The third thing is it is not compatible with phenomenal internalism and cannot account for cases of coincidental variation. This is more on the side with psychophysics, that there are some results that tracking representations cannot accommodate. And fourth is that it is committed to color physicalism, or like also in other terms of other like secondary qualities like sounds and smells. It is committed to a physicalist view, which itself then faces several difficulties, such as metamerism in the case of colors. And yeah, I cannot go into detail here. These are just like the main objections against tracking representationalism. And so this gives us the following diagnosis. Tracking representationalism is in serious trouble, but we can see, if we would examine these objections in more detail, we can see that all the difficulties are due to the tracking theory and its externalist commitment. So all these objections have something to do with endorsing the tracking theory as an account of mental representation. And so I think that the idea of representationalism in principle is on the right track. And so we need just another account of representation. And as I said, the tracking theory is, in its most varieties, an externalist account of mental representation. And because this all creates the difficulties, my, looking for a new theory of representation, I try to focus on internalist accounts of representation. Okay, now, what could such an account be? And I suggested a possible solution is pretty much easier to find than we might think at first, and it is structural correspondence. And a paradigmatic case of structural correspondence are cartographic maps. And so here you can see a map of Rome. And now why does this map of Rome represent the city of Rome? Yeah, it is because we have here the points on the map, and they correspond to particular places in the city of Rome, and the distances between the points on this map also correspond to the distances between the locations in the city of Rome. And more formally then, the structures account holds that X represents Y, just in case X structurally corresponds to Y. Then of course we need to say a bit more about what is structural correspondence. And structural correspondence is usually cashed out by saying this: X structurally corresponds to Y if and only if there is a structure preserving mapping from X to Y. So we need to be able to map one domain onto the other. And mostly, probably at first we might think of isomorphisms, but because isomorphisms are like really difficult to find. Usually it is cashed out in terms of homomorphisms, which are a bit more relaxed. And I mean, there is much more to say about this, but I will just like just have like this very rough impression for you, because I think it is enough to for this talk. Okay, and so what is important in the case of structural representation is that at both ends of the representation relation, so at the end of the thing that does the representing and the thing that is represented, according to this account, we find relational structures. And a relational structure is just a set of elements with relations defined on them, to give a very like superficial account of this. But this is important so that it is like representation on this view is a relation between relational structures. Now there's the liberality problem. And this problem is that there are many things that structurally correspond to each other without one representing the other. So this is to say that like structural correspondence is not sufficient for representation. For example, there might be a structural correspondence between the items in my refrigerator and the cars parked in the yard behind my apartment, but there seems to be no representational relation between them. Neither do the cars represent the items in the refrigerator or the other way around. Another example would be a structural correspondence between rock formations on a distant planet and some of my neural states. So I don't think that my neural states then would represent these rock formations. Maybe they do under some special circumstances, but just the structural correspondence as such does not seem to be like sufficient for providing the basis for representation. And so we need some further constraint on the structural correspondence relation. And like the most popular account on this is given by Nick Scher, and he says that we need to add exploitability as an additional constraint. So a structural correspondence relation needs to be exploitable in order to provide the basis for representation. And in his view, a structural correspondence is exploitable if, and now we get back to the both relational structures, if the relation on the elements of the representatum, so that this is the structure that does the representing, and the relation defined on the elements of this structure is such that the processing of the representing system is sensitive to this relation, and on the other hand, the relation on the elements of the representandum, that is the thing that is represented, is such that it is significant for the representing system. I mean, there are some further problems with this view, but I think it gives us a bit like a better view to say that structural correspondence, if it is exploitable, might provide the ground for representation. Okay, now, how does this help us to say something about conscious representation? And then, of course, we first need to know what are the relevant relational structures involved here. And then my proposal is to say that at the representatum end, so at the end where we find the relational structure that is relevant for representing, we find neural activation spaces. And at the other end of the representation relation, we find quality spaces. And I think Lukas has already told us a lot about quality spaces, and I think also about neural activation spaces. But just to give you a brief overview, a quality space, very generally put, is a multidimensional ordering of the qualities presented by experiences in a given sensory modality in terms of their relative similarity. So like in the case of the color quality space, we can sort colors in terms of their relative similarity, and then we get the space. And what is also important, in my view, is that a quality space captures the totality of discriminations an individual can make with the corresponding sensory modality. So this is to say the quality space, for example, the color quality space, is restrained by our discriminatory abilities to distinguish between visual stimuli. And this then means that quality spaces are ultimately determined by discriminatory abilities, which in turn are fixed by the overall makeup, organization, and condition of the corresponding sensory system. So on this view, like the sensory system somehow constrains the quality space. And we have here the color quality space, and I tried to pick this graphic because there you can just see the space without being colored. I mean, just like, don't think of the disk at the left. And so here we can see also that the color space is three-dimensional, and on my view, this has to do with the fact that also like our visual color processing is such that we can discriminate between colors in 3 dimensions, namely in hue, saturation, and brightness, and this is why it gives us this three-dimensional color space. Like, I mean, we have seen, Lucas, maybe you had a somewhat better graph, because it showed that it's like color space can also be like somehow like shaped in a very different way and does not need to be as symmetrical as here. And so, but this is just to give you like an idea of how we can think of color spaces in relations to discriminatory abilities. Okay, now I think we have heard enough about color quality spaces, and I just go on to the neural activation spaces. And like a particular state of a neural network at a given time, on my view, is one and the same as the activity pattern displayed by the entire neural network at the time. And now individual states of a neural network then may resemble one another with respect to the activity pattern to a greater or lesser extent. And this also then gives us the possibility to sort them and construct an ordering in terms of the similarity. And then a neural activation space is just a multidimensional state space structuring the totality of possible states of a given neural network in terms of the relative similarity of their activity patterns. And now we have these two spaces, quality spaces and neural activation spaces. Here is one example. This is for the retinal ganglion cells, but I just may skip it because of time constraints. And now what we get is, up till now, we only have this correspondence between two spaces. But of course, we are normally interested in like what a particular state represents. Not only just saying, oh, there's a space and this space represents another space, but we want to know what this state represents. And according to Cummins, there's also partial representation. And this is to say that structural correspondence also provides the ground for some derivative representational facts and relations. And among these are elements of the representing structure represent elements of the represented structure, relations represent other relations, and states of affairs. If we go back to the map of Rome, for example, this is to say that a particular point on the map represents a particular location in Rome, a particular relation such as the distance between A and B on the map represents the location between the represented locations in the city of Rome, and this holds also for states of affairs if we compare distance relations, for example. So such as like A is closer to B than it is to C, and this is also like a partial representation. And now these partial representations, they like accrue their virtue as representations in virtue of being embedded into the whole structure. And the upshot is then that, on my view, a neural state N, so a particular state, represents a quality Q, a particular quality, if and only if there is a structure preserving mapping M from the neural activation space in which N is embedded onto the quality space in which Q is embedded, and this mapping M maps N onto Q. And so this is how a neural state gets its content. And the core thesis then is to say that the phenomenal character of an experience is exhausted in the quality the underlying neural state structurally corresponds to. And so maybe this is the point then where I depart from Lucas, because you maybe would say, okay, whether phenomenal character is a matter of representing just this quality, this is not clear. But I would say, yes, this is just what it is to have a phenomenal experience with a particular phenomenal character. And like I said, this then also shows us that structuralist representationalism only addresses the hard problem in its specific version and not in its general version. So we still need some additional account as to why this particular neural state N is phenomenally conscious rather than not. And just to give you a brief example, the phenomenal character of a color experience, for example, is exhausted in the quality onto which the underlying neural state is mapped by a structure preserving mapping from the neural activation space in which it is embedded. So that must be the neural activation space corresponding to color experience. And this is mapped onto the color, mapped onto particular color quality that is represented. Okay, do I have some time for implications? But maybe it's what Lucas already said before. There's this mirroring thesis, which says that phenomenal structure is mirrored in neural structure. There is the thesis of phenomenal structuralism, which says that phenomenal character is a purely relational affair, in contrast to being an intrinsic affair. And the thesis of phenomenal holism. Each phenomenal character is interconnected with all other phenomenal characters inhabiting the same phenomenal space, and it can only be individuated in terms of its relative position within that phenomenal space. So we cannot say something about red other than by saying everything about how it relates to other phenomenal characters. And these points, I think, are also is what neurophenomenal structuralism says. So this is the position defended by you, Lucas, and your colleagues Holger Liere and Sascha Fink. And so my position entails this, but like somehow goes a bit further by saying that phenomenal character is nothing than structural representation. Okay, so that's it.